In example 2.1j, we're going to be looking at the last of our parent functions, and this one is going to be a little different from the others. There's no exponent involved in this. There is no add, subtract, multiply, divide involved in this. But I will say that the domain for this function is going to be all real numbers. So we can define this f r to r by the equation f of x equals, so the symbol that you see around the x, this is a double bar bracket, and this is what gives us the function that we're dealing with. And the name of this function is called the greatest integer function. So that's how you define the function. Now I want to look at making a table to help us with the graphing. So all of the other examples we've seen here in 2.1, all the other functions, we've been able to use, well, real numbers, but we didn't have to get real creative with the real numbers we chose. We could just choose integers. If all we do is choose integers for the table, we're going to miss out on some of the detail that makes this function different than any of the others that we've seen. So we want to be real careful about the values that we select. Now once we select a few values, you'll hopefully see the pattern, and then you can go straight to finishing the graph that way. So I'm going to select some values for us. I'm going to select 0, 0.2, 0.5, 0.7, let's say 1, 1.1, and how about 1.4? And we'll start with these. If we need to add more, we always can. And starting with 0, I'll go ahead and tell you that 0 is going to map to 0 for the greatest integer function. 0.2 will also map to 0, as will 0.5 and 0.7. But if I try to plug in 1, I map to 1. 1.1 is going to map to 1. 1.4 is going to map to 1. So essentially what we have here is a function that always takes your value and rounds it down. Now when we're talking about 0 and 1, those are already integers to start with, so we don't have to round those down. But on all of these and these two examples here, 0.2, 0.5, 0.7, 1.1, and 1.4 are all decimals. They're not integers. So you round them down to the closest integer that you would have. So everything rounds down. That's what this thing does. So from a graphing perspective, what we're going to get is, starting with the zeros, we have 0, 0. We're also going to have several other points, 0.20, 0.5, 0.7, and it's really difficult for me to show all of those things with a great amount of detail on the graph. But what I do know is that all of the decimals that look like 0.2, 0.5, so that would be things like 0.1, 0.3, and even the decimals that have 2 decimal places, 3, so on and so forth, all of those would round down to 0. So what that's really going to amount to for me, instead of trying to make all these little points in between 0 and 1, I'm going to put an open circle at 1, and then I'm going to make a line to connect everything from 0 to 1, because those would be all the values that should map to 0. Then I go to the next set of entries, and all of those entries end up rounding down to 1. So the first of those would be 1, which doesn't really round down, it just maps to itself, because there's no rounding that's needed for 1, that first point, 1, 1. And then any of the other 1.1, 1.2, 1.3, 1.4, those would also map to 1. So I'll put an open circle at 2, and I'll connect and I get 2 of these horizontal lines. And if I continue this pattern, and I can do so all the way across the coordinate grid, I'm going to get all these little horizontal pieces. And when we're graphing, we always want to graph everything in the domain. But we really won't be able to graph everything in the domain because the window that we're using is not infinite. It's not going to last forever. So there's only a finite amount of space here. So you always want to take your graph as far as you possibly can on the window that you're provided. So that would get me all the way up here to the point at 1010. That's as far as I can go. But this pattern also continues in the negative x value direction, which would take us into the third quadrant because, after all, the domain is going to be all real numbers. So going backwards with this, I can continue this. I've heard this called a stair step is the way that this looks, which actually is not far from one of the nicknames. So let me complete the picture, and then I'll write down the nickname for this. So that takes us to the end there, and the nickname for this is called a step function.